Welcome to the deep dive. We're here to cut through the noise, taking the sources you provide and pulling out the key insights you actually need.
Exactly. And today we're diving into something pretty fundamental. Log data. We've got a great mix of materials to work from.
Yeah, seems like we have core concepts, an incident handlers template, some RFC standards for time and syslog, and even Splunk documentation. Quite the range.
It really is. So the goal today is to, unpack what logs are, why time matters so much, how things like syslog work, and then how a platform like Splunk helps make sense of it all.
Right. For security, for operations, basically understanding what your systems are doing.
Okay, let's set that as our mission then. Understand logging, time, transport, and analysis. Sounds good.
Sounds like a plan. Let's start at the beginning. What is a log? Fundamentally, it's just a record, right? An event happening on a computer or network,
Just a record. Simple enough. And logging is just the act of making that record.
pretty much. But then you get to log management. That's the bigger picture.
Yeah.
Collecting them, storing them, analyzing them, eventually getting rid of them, the whole life cycle.
Exactly. And the analysis part, well, that's key. Digging through those logs to find the important stuff, the events of interest, as the source calls them.
Events of interest. Could be anything from a simple error message to, well, something more serious.
Definitely. That's where things like SIME come in security information and event management.
Ah, the log detectives. Pulling data from everywhere.
Yeah, correlating events, looking for suspicious activity across the board. And you've also got intrusion detection systems, IDS.
Right, the specific guards. HIDS for hosts, NIDS for the network traffic itself.
Uh-huh. They're actively watching for signs of trouble, but, they're not perfect.
You mean false positives?
Exactly. Getting an alert when nothing's actually wrong, it's a constant balancing act in security, catching the real threats without drowning in false alarms.
Okay, so logs are vital records, but just having a pile of them isn't enough.
Yeah,
You mentioned time earlier. That seems crucial, doesn't it? Especially when things go wrong.
absolutely critical. If you don't know when something happened precisely, putting the pieces together is almost impossible. Think about troubleshooting or investigating a breach. Timing is everything.
Which leads us nicely into standards, I guess, like RFC 33389, date and time on the internet, timestamps. Sounds official.
It is. It basically profiles the ISO 8601 standard specifically for internet use. The really neat thing is how it structures the time components.
Also,
It goes from least precise to most precise year, month, day, then hour, minute, second. So if everything's in the same format, same time zone.
you can just sort the timestamps alphabetically or like as text strings, and they'll be in chronological order.
Exactly. That's a huge deal when you're dealing with logs from tons of different sources.
Yeah.
Saves so much parsing hassle.
Wow, okay. That is clever. So what does one of these timestamps actually look like?
Well, the basic format is full date, then a literal T separator, then the full time. Something like 2024 10, 2017 10.30.00Z.
And the Z, what's that?
Z stands for Zulu time, which means UTC Coordinated Universal Time, the global standard. Using uppercase T and Z is recommended, by the way, avoids potential issues.
Okay, UTC. Makes sense. What if it's not UTC?
Then you'll see an offset, like -05.00 for 5 hours behind UTC. So maybe 2024 10, 2017 05.300005.00. The standard even covers leap seconds, though that's pretty rare.
Lead seconds, right. Those occasional extra seconds. Always a fun detail.
Yeah, you might see like 23.59.60Z during a leap second event. But the key is that UTC provides that unambiguous point in time.
Unambiguous. That's the goal. No matter where you are, that time means the same instant.
Precisely. And the RFC mentions ABNF too.
ABNF, augmented Bacchus-Naur form. Sounds intense.
It is a bit technical. Think of it like a super strict grammar for computers. The RFC uses it to formally define the timestamp format, trying to nail down any potential ambiguities from the base ISO standards.
So it's about making sure everyone formats time exactly the same way so systems can understand each other perfectly.
You got it. Eliminating guesswork, it defines all the parts like date, year, time, hour, time zone, very rigorously.
Okay, events logged, timestamps standardized. Now, how do we get these logs from, say, a web server over to a central place for that analysis we talked about?
Good question. That's often where syslog comes into play. RFC 5424, the syslog protocol.
Syslog, heard of it. What's the core idea?
It's a standard protocol designed specifically for sending event notification messages logs, essentially. It has a layered structure, which is smart. It separates the message content from how it gets transported.
Separates content from transport. Why is that good?
Makes it flexible. You can use different network protocols underneath, like UDP or TCP, and you can extend the message format without breaking the core protocol.
Okay. And the messages themselves, do they have a standard structure?
They do. There's a header with priority, timestamp, host name, app name, things like that, and then the message body. But crucially, there's also support for structured data.
Structured data.
Yeah.
Sounds useful. Like key value pairs.
Exactly like that. Define elements with specific IDs. So instead of just having a free-form text message, you can have fields like origin IP 192.0.2.1 or time quality tsnone1 is synced 1.
Ah, so that makes automatic parsing and analysis way easier.
Way easier. You know exactly where to find the IP address or info about the timestamp's reliability. Vendors can add their own structured data, too.
And how does this flow typically work? Who sends what to whom?
You have originators, the devices generating the logs, and collectors, the servers receiving them. Often you'll also have relays in the middle.
Relays, like aggregators.
Yeah, they can receive logs from many sources and forward them on, maybe to multiple collectors. Helps manage traffic in larger networks.
What about the actual message part, the NSG field? Anything special there?
It's usually human-readable text. The RFC says it can be UTF-8 encoded, which supports lots of characters. If it is, it should ideally use the shortest form and might have a BOM, a byte order mark, to signal the encoding.
Got it. Now, security. Logging sensitive info is standard syslog secure.
Ugh, that's a big consideration. Traditional syslog, especially over UDP, offers very little security out of the box. No encryption, no strong authentication usually.
So messages could be intercepted.
Yeah.
Or tampered with.
Potentially, yes.
Yeah.
Eavesdropping, message modification, replay attacks where old messages are resent. Those are risks. Plus, denial of service if someone floods the collector.
Oof. So what does RFC 54284 suggest?
It strongly recommends using reliable, secure transport mechanisms underneath, like TCP with TLS encryption, and securing the network path itself. It also warns about trying to identify things based solely on the message content because of potential spoofing, especially with Unicode characters.
Okay, so syslog is the transport standard,
Right.
but you need to layer security on top in most real-world cases.
Yeah.
Makes sense.
Definitely.
Right, so now we have potentially millions of log entries, maybe coming in via syslog, all nicely timestamped. How on earth do we make sense of that fire hose of data?
Yeah, that's the challenge. And that's where platforms like Splunk Cloud Platform really shine. They're built for this.
Splunk. Okay,
Mhm.
so it takes all this raw data and does what?
It consumes it, processes it through what they call a data pipeline, indexes it, and transforms it into searchable events, basically turning machine data into, well, knowledge you can actually use.
How does the data usually get into Splunk Cloud in the first place?
Very often through forwarders, little software agents you install on the machines you want to collect logs from.
Agents, okay. Are there different kinds?
Yep, two main types, universal forwarders and heavy forwarders. Universal forwarders, or UFs, are lightweight, designed to just collect and send data efficiently. Minimal footprint.
Good for deploying everywhere, then.
Exactly. Then you have heavy forwarders, or HFs. These are basically full Splunk enterprise instances, but usually with indexing turned off.
A full Splunk instance, why would you use that just to forward?
Because they can do more processing before sending the data on. They can parse events, filter out noise, mask sensitive data. They have the whole Splunk processing capability.
Ah, so a heavy forwarder could, like, pre-process logs from a bunch of universal forwarders before sending a cleaner stream to the main Splunk Cloud instance.
Precisely. It can act as an aggregation point, a filtering layer, or handle complex parsing tasks. Also useful for data sources where you can't install a UF, like network devices sending syslog. The HF can listen for that syslog traffic.
Okay, that makes sense. So whether it's a UF, an HF, or some other method, data's arriving at Splunk. What's the next step inside Splunk?
You need to tell Splunk how to handle that data. This happens during the adding data process, which you can usually do through the Splunk web UI or the command line. Options like upload, monitor, forward.
Right, and a key part of that is assigning a source type, isn't it?
Absolutely crucial. The source type tells Splunk everything about how to interpret that data stream, how to break it into events, where to find the timestamp, how to extract fields.
Does Splunk guess the source type?
It tries its best. It has tons of built-in source types for common formats, Apache logs, Windows event logs, syslog, JSON, CSV, and it'll try to auto-detect. But sometimes you need to choose one manually or even define a custom source type if your data is unique.
And there's a set source type page mentioned. for tweaking this.
Yeah, that's super helpful. You can upload a sample file, pick a source type, and it shows you a preview of how Splunk will break it into events and extract timestamps based on that source type settings. You can adjust things right there.
Can you preview network data too? Like syslog?
Not directly on that page in the same way as a file upload, but you could capture some network traffic to a file first, then upload that file to the previewer to test your source type settings. It's a common workaround.
Got it. Okay, for files, you mentioned monitor and upload inputs. When use which?
Monitor is for ongoing data. Log files that are constantly being written to. Splunk keeps track and reads new data as it appears. Upload is for a one-time ingestion, like if you have an old log archive, maybe a zip file you want to get into Splunk.
And Splunk can unzip archives.
Yep, it handles common archive formats like zip and targz automatically before processing the contents. There's also that special monitor no-handle input for Windows, specifically for log files that get rotated frequently. Helps avoid missing data during the rotation.
You also heard about the command line interface, the CLI, for inputs.
Right, very useful for scripting and automation. Commands like Splunk add monitor or Splunk add one shot let you configure inputs without using the web interface.
But for really fine-grained control, you probably edit inputs.conf directly.
Definitely. Inputs.conf is where the real power lies for input configuration. You define stanzas for each input, specifying paths. You can use wildcards, source types, target indexes, all sorts of options, usually in CFL on home system local or an apps local directory.
How does Splunk know where it left off in a monitored file if, say, the forwarder restarts?
It's clever. It calculates a CRC, a checksum, of the first part of the file and remembers the byte offset, the seek address where it stopped reading. When it restarts, it finds the file, checks the CRC to make sure it's likely the same file, and picks up reading from the saved offset.
Prevents re-indexing the whole file.
Exactly. It also periodically checks for files that might have gone missing and come back. It's generally robust, though sometimes tricky with files that get heavily modified in place.
Okay, what about network inputs? Listening for TCP or UDP traffic directly.
Yep, you can figure those in inputs.conf too. Stanzas like tcp.port or udp.port. You specify the port, maybe restrict source IPs, define the source type, and choose how the host field gets set IP, DNS lookup, or a fixed value.
And how does it handle incoming syslog specifically?
If you set up a UEP input, say on port 514, and tell Splunk the source type is syslog, it knows what to expect. It'll typically prepend its own timestamp when it received the data, and the sender's hostname IP to the event.
What about SNMP? Is that built in?
No native SNMP trap input directly in the core product, but there are apps on Splunk base that add that capability. Or often you can configure your SNMP management tool to write traps to a file and then just monitor that file with Splunk.
Makes sense. Now, Windows.
Yeah.
Lots of specific data sources there. How does Splunk grab those?
Typically using a forwarder installed on the Windows machine. That forwarder can then tap into Windows event logs, monitor the registry, query Active Directory, collect performance counters via WMI, run PowerShell scripts. Lots of options.
Event logs seem like a big one. How do you configure that?
In inputs.conf, you use stanzas like wineeventlog.security or wineeventlog.application. You specify the channel name. You can tell it where to start reading, oldest or current, how often to checkpoint its position, and even tell it to try and resolve AD object SIDs to names.
Did you filter which events get collected? Those logs can be noisy.
Oh yeah. You have whitelist and blacklist settings right in the stanza. You can filter by event ID or use more complex key value filtering with regex support. Combine filters with AND logic on one line or use numbered entries for OR logic. Very flexible.
And you mentioned WMI earlier.
Right.
For remote data collection.
Right. Windows management instrumentation. Splunk can use WMI to pull data from remote Windows machines without needing a forwarder on that remote machine, although you need one somewhere to initiate the query. Needs proper network setup and permissions, though. What the Splunk process can access remotely depends on the user account it runs as.
How do you set up WMI inputs?
Again, inputs.conf. Stanzas like wmi.perfmon for performance counters. You specify the WMI namespace, the query using WQL, the counters, instances, and the polling interval. You can only monitor one WMI object per stanza, usually.
What about running custom scripts on Windows?
PowerShell inputs are great for that. Use a script.stanza, point it to your .ps1 file, and set a schedule. Splunk runs the script and ingests whatever it outputs to standard out.
There was also Windows host monitoring. What's that collect?
That's a specific input type designed to gather OS and hardware inventory-like info. CPU, memory, disk, network configs, installed software, running processes. Needs a forwarder running locally, ideally as local system or an admin.
And even capturing raw network packets on Windows.
Yep, local Windows network monitoring uses WinNetMon stanzas. You can specify things like IPv4 versus IPv6, packet types, connects, accepts, and direction, inbound bound.
Okay, one more major input method, HEC HTTP Event Collector. Sounds different.
It is. It's an API-based approach. You send data to Splunk via HTTP or HTTPS POST requests, authenticated using tokens you generate in Splunk.
Why use HEC instead of a forwarder?
Great for applications, microservices, serverless functions, or cloud services that can easily make HTTP requests. No need to install a forwarder agent. You just format your data, often as JSON, and post it to the HEC endpoint.
So developers can integrate logging directly into their apps.
Exactly. It's very popular for that. You can send single events or batch them up. You can specify metadata like host, source type, and index right in the JSON payload or HTTP headers.
Convenient. How do you check if it's working?
There's an acknowledgement feature you can use to confirm indexing. Plus, Splunk logs HEC activity internally, and the monitoring console has dedicated dashboards to track HEC traffic, errors, and token usage.
Got it. We also saw scripted inputs mentioned generally, not just PowerShell.
Right, that's the cross-platform way. Run any script, Python, Shell, Perl, on a schedule, and Splunk ingests its standard output, configured via script.inputs.con. Super flexible for custom data gathering, like running top periodically on Linux, for instance.
And for Linux specifically, there's journaled input.
Yes, for systems using systemd, Splunk can pull logs directly from the journal using journal.stanzas. You can filter by fields, units, apply grep patterns. Quite powerful for modern Linux systems.
And a similar logged input for macOS.
Correct, for the macOS unified logging system.
Okay, data's flowing in from all these sources. Now, the processing pipeline inside Splunk. What happens first?
Well, Splunk needs to read the characters correctly. So character set encoding, charse it in props.com. It tries to auto-detect, but you can specify it if needed.
Then it needs to figure out where one event ends and the next begins. Line breaking.
Exactly. Line breaker in props.com defines the pattern, usually new line characters. But for multi-line events like stack traces, you might need more complex rules or line merging settings, should line merge. Getting the line breaking right up front is usually most efficient.
What about sensitive data? Can Splunk help hide that during ingestion?
Yes. Through anonymization using scdcmd in props.com, you define sub-substitution rules to mask or remove things like credit card numbers or PII before the data hits the index.
And timestamps. Again, how does Splunk find the time in the event?
It has built-in logic to recognize common timestamp formats. But if your format is weird or it guesses wrong, you use time format in props.com to provide a specific pattern using strap-time syntax. Max timestamp lookahead tells it how many characters into the event to search. Getting this wrong means your events might have incorrect times in Splunk, which messes up searching and alerting.
So, test carefully.
Always test timestamp settings, maybe on a small data sample or a test indexer. Reindexing might be needed if you change it later.
Okay, events are broken, time-stamped. Then Splunk adds fields, like host, source type.
Right. Those are key default fields extracted during indexing. Raw holds the original text, time is the epoch timestamp. Host identifies the source machine, source identifies the input file or stream, and source type identifies the data format.
Do you add more fields automatically during indexing?
Yes. That's indexed field extraction, usually done via transforms.conf, defining the regex for format, and props.con, applying the transform to a source type. You define a regex to capture a value and a format to assign it to a field name. For structured data like CSV, it can often do this automatically based on headers.
What about doing calculations or lookups as data comes in? Ingest time evil.
Yeah, that allows you to use Splunk's evil command logic before indexing. You could calculate a duration, categorize an event based on a field value, or enrich events by looking up an IP address in a threat list, for example.
We talked about setting the host field. Can you customize how that's done?
Yes, in inputs.conf for file monitoring, you can use host regex to extract the host name from the file path, or a host segment to use a specific part of the path. Gives you more control than just using the forwarder's host name.
And source types, too. Can they be assigned dynamically?
Definitely. Besides setting it per input, you can use rules in sourcetypes.com based on data patterns, or use transforms in props.com and transforms.com to set the source type based on event content. Regex, format, source type.value, desk key, metadata.source type.
What about time zones? How are those handled?
You can configure time zone settings in props.com, TZ. Splunk tries to parse time zone info from timestamps if present, but you can set defaults. Internally, it normalizes to UTC.
And event segmentation. Sounds like breaking fields down further.
It's about how Splunk breaks the raw text into searchable terms or segments, configurable in props.com and segmenters.com. Usually handled automatically, but tunable for specific data types.
Can you store different data in different places within Splunk, custom indexes?
Yes, very common. You create custom indexes, e.g. index web, index security, to separate data logically, control retention times, manage access, and optimize searches. You specify the target index in your inputs.com stanzas.
What happens if a forwarder can't reach the indexer? Does data get lost?
Not if you enable persistent queuing on the forwarder. Persistent queue size in outputs.com, actually. The forwarder writes data to a disk queue if the connection is down and sends it when the connection comes back up. Prevents data loss during outages.
Okay, finally, ingest actions. How do these fit in? Are they different from editing comp files?
They are a more UI-driven way, often configured centrally, to apply transformations before indexing. Think masking data, filtering events, setting the index, or even routing data to S3. It's aimed at simplifying common pre-indexing tasks without needing deep comp file knowledge.
So similar goals to transforms and props, but maybe easier for some use cases.
Yeah,
And happens on the indexer or heavy forwarder.
right. It operates on the indexing tier, applying rule sets you define. It overlaps conceptually with things like SED-CMD or filtering transforms, but provides a different interface and management approach.
And last bits on troubleshooting, fish bucket and ingestion congestion.
The fish bucket is Splunk's internal tracking database for monitored files, CRC seek pointer stuff. You can monitor its state via REST if you suspect issues like duplicate indexing. Ingestion congestion means the indexer can't keep up, sometimes caused by too many inactive input connections, tunable and limits.conf, max inactive. But often, the root cause goes back to inefficient event breaking or timestamp rules.
Wow. Okay, that was a lot, but super informative.
It really covers the whole journey, doesn't it? From the raw event happening on a system, getting timestamped according to standards like RFC 3339, transported via something like syslog following RFC 5424, and then ingested, processed, and made searchable by a platform like Splunk.
Yeah, understanding each piece, the log itself, the timestamp, the transport, the analysis platform, it all fits together.
Yeah.
Crucial for anyone in IT ops, security, really anyone dealing with system data.
Absolutely, and seeing how Splunk provides so many ways to get data in, configure parsing, and manage the flow, universal forwarders, heavy forwarders, HEC, network inputs, specific Windows methods, scripted inputs, it's incredibly flexible.
It really highlights how fundamental this stuff is. So thinking ahead, with data volumes just exploding, what's the next evolution? How do we keep managing and securing all this, building on these foundations we talked about?
That's the million-dollar question, isn't it? Faster processing, maybe more intelligence, moving closer to the source, like with edge processors, smarter correlation, better handling of massively diverse data structures. It'll definitely keep evolving.
Something for us all to think about. Definitely check out the source materials if you want to go even deeper. Thanks for joining this deep dive.